नमस्ते। आज मैं बात करने वाला हूँ आपसे स्टेबल और अनस्टेबल सिस्टम्स के क्लासिफिकेशंस के बारे में। सिस्टम स्टेबल कैसे होता है और अनस्टेबल कैसे होता है, क्यों होता है, कौन से सिस्टम्स होते हैं और उनको हम कैसे चेक करते हैं कि सिस्टम स्टेबल है कि अनस्टेबल है, इसके बारे में बात करेंगे। स्टेबिलिटी बहुत ज़्यादा इम्पोर्टेंट है। कुछ लोग कहते हैं कि नहीं जॉब स्टेबल होना चाहिए, कुछ लोग कहते हैं नहीं सिस्टम ही हमारा बहुत ख़राब है, स्टेबल नहीं है, कोई स्टेबिलिटी नहीं है लाइफ में, बहुत सारी प्रॉब्लम्स चल रही हैं। ये सब स्टेबिलिटी लोग सीख करते हैं, लोग खोज रहे हैं कि स्टेबल हो जाऊँ, मैं हैप्पी हो जाऊँ, मेरी लाइफ में कुछ स्टेबल नहीं चल रहा है। ऐसी सब प्रॉब्लम्स को कई लोग फेस कर रहे हैं। तो वो सब स्टेबिलिटी लाइफ के बारे में। बट यहाँ पे हमारा जो ऑब्जेक्टिव है वो सिस्टम्स की स्टेबिलिटी का से रिलेटेड है। तो सिस्टम्स भी स्टेबल हो ऐसा सब कोई चाहता है, कि हर कोई चाहता है कि हम जो सर्किट बनाएं या जो डिज़ाइन बनाएं या जो भी सिस्टम हम लोग डेवलप करें वो स्टेबल होना चाहिए। तो सिस्टम्स स्टेबल होने का मतलब क्या है कि सिस्टम को हम डिस्टर्ब करें, थोड़ा सा डिस्टर्ब करें तो सिस्टम की जो स्टेट है, स्टेट मीन्स इक्विलिब्रियम स्टेट में अगर सिस्टम है तो वो उसी स्टेट में रहे, या थोड़ी देर बाद इमीडिएटली वो अपने वापस इक्विलिब्रियम स्टेट में आ जाता है, तो इस सिस्टम को हम कहते हैं स्टेबल है, इसमें स्टेबिलिटी है। या इसको इस टाइप के जो स्टेबिलिटी है उसको कहते हैं इंटरनल स्टेबिलिटी। So if I disturb a system, if a system is in equilibrium state and a small disturbance is given to the system and system comes back to its equilibrium state again, then this system is internally stable. And a system is externally stable if I give an external input to the system and the output is in control, output is in measurable amount, then the system is externally stable. So this external stability is measured by a bounded input and bounded output. Means if I provide a bounded input to a system, then the system produces a bounded output. That system is called externally stable. Means this is stable to the external inputs. Okay. If you have understood, let me take one system. This system should be stable internally also, and this system should be stable externally also. So this should have internal stability as well as external stability. External stability can be measured, or and so overall if a system have both kind of stability, that means it is externally stable as well as internally stable, then this is called a stable system. Stable system is very important and very useful in life. These systems are less noisy, they provide a measurable output, so that output can be measured by using available instruments. These systems have applications in audio signals, seismic signals, circuits, networks, signal processing, control systems, communication systems, and other technical areas. These systems have reliable performance. They provide consistent and predictable output. Even they can be useful for the critical applications. The systems which are stable, they have reduced downtime. There are fewer crashes in the system. There are fewer errors in the system. There are fewer malfunctions in the system. Therefore, operations of the systems are not disrupted in between. And the as the systems do not have disturbances, they have increased productivity also. They have lesser maintenance cost also. There are less updates, less repairs. Therefore, they require less maintenance cost. Stability is this very important feature of the system. You can say stable system is can be uh, should have a can be completely stable, can be conditionally stable, can be marginally stable. Here I'm so the stability can the stable systems can also be of three types. They can be completely stable, marginally stable, or conditionally stable. So this type of stability is discussed in the networks and the control system subject. Here I will consider only two types, means binary classification of the systems as stable and unstable. हम लोग बात करेंगे सिर्फ stable और unstable की. The internal types of stability will be discussed later on in the control systems. Okay, but here I'm going to discuss only stable part, means how to identify the system whether it is stable or it is unstable. Okay. The methods for calculating, checking the stability of a system are, first one is, as I have told, the system should have a bounded output to bounded input. So that type of checking stability is called BIBO method, bounded input, bounded output method of checking stability. Second method is impulse response method, that is for the LTI systems. So by using impulse response, we can check the stability of the system. There is method of pole zero method. So when you will study or when you know the transfer function in the form of Laplace transform or in the form of Z transform, then by using poles, location of poles and poles, you can say the stability, you can tell about the stability of the system. Other methods are like Routh-Hurwitz method and root locus method and Nyquist plot method and state space method. These methods are beyond our scope. They are not in our syllabus right now, or signals at the signal system time. When you study the control system, at that time those all methods will be discussed. Okay, at this time I will be discussing only two methods. First one is bounded input and bounded output method, and second one is impulse response method. Let us see the bounded input and bounded output method of checking the stability of system. So if I have a system, one input is provided. So if it is a bounded input, stable system, if I have a stable system and bounded input signal is given to this stable system, then if it will provide a bounded output signal. What is bounded signal? I'm just coming to that point. Bounded input signal or bounded output signal. Bounded signal means the signals which are which never touch the infinity. So bounded signal, examples of bounded signal are U of t. U of t is always having values less than infinity. It never touches infinity in its lifetime. DC values, sin t, cos t, these signals never touch infinity in their lifetime. Therefore, these signals are bounded signals. They are bounded in a particular limits. And those signals which touch uh, infinity, they are called unbounded signals. For example, e to the power x, 10t, like that. These are unbounded signals. Okay. I have already discussed in a video the signals in the unit, first unit. What are the bounded signals and unbounded signals? You can watch that video and see in detail. I have given many examples. Okay. So if I provide this bounded input signal to an unstable system, then definitely there will be unbounded output. I will get unbounded output signal. Okay, it is sure. Other two possibilities are there, that I may give the unbounded input. So unbounded input, if I give unbounded input to a system, to a stable system, then there is two possibility. It may give bounded output or it may give unbounded output. It is not sure for the unbounded input signal whether it will give a bounded or unbounded. Okay. Same in the unstable system. So we do not check for the unbounded inputs. You have not check for the unbounded input. Unstable system can also provide. It can provide bounded or it can provide unbounded. It is not sure that whether it will be bounded or unbounded. Therefore, we will not check for these kind of signals. Okay, so these are not to be checked. What to be checked? We will check only for the bounded inputs. So this is, if bounded output is coming, then that is a stable system. For bounded inputs, if unbounded output is coming, then that is a unstable system. Okay. Let us go further. If I have signal yt equal to txt, example 1, if I have signal yt equal to t times xt. So this signal is providing so we have to check it for the bounded. So if I give a bounded input u of t to this system, then output yt will be equal to t times u of t. T times of u of t is ramp signal rt, and this ramp signal is unbounded signal, because at infinity its value is infinity. Therefore, ramp is unbounded signal. So for the bounded input is bounded and output of the system is unbounded. Therefore, this system is unstable system. Okay, so this system yt equal to txt is a unstable system. Another example, number 2, if I have yt equal to 2 plus xt, then if input is ut, then yt equal to 2 plus ut, it is bounded. If xt equal to 5, then yt equal to 7. So for bounded input, output is bounded. As I think of all the bounded for xt equal to, if xt is sin t bounded, then yt equal to sin t plus 2, which is also bounded. So for this bounded input, output is bounded. For all kind of bounded inputs, output is bounded. Therefore, this is a stable system. The system is stable. This is stable system. Okay. Let us take some more example. If I have example 3, yt is equal to sine of xt. So for xt, whatever values of xt, so yt, whatever means yt equal to, it will be sine of some bounded input, sine of bounded input. And we know that the value of sine is between -1 to 1, which is bounded. Therefore, output is always bounded. Output is always bounded. Input may be unbounded, but input may be bounded, but output is surely bounded. Therefore, it is stable system. Which stable system? Example number 4. Suppose yt equal to है, yt is equal to minus infinity to t xt dt. If xt equal to 2, then yt equal to 2t. 2 t में हो जाएगा आपका t minus infinity. Okay, it will be infinity, minus infinity, or infinity value, so unbounded. Therefore, unstable system. If I have one more example, let us take example number 5. Yt is equal to d by dt of xt. This looks to be bounded, but for if xt is equal to ut, which is bounded, yt is delta t is unbounded. For bounded input, there is unbounded output. Therefore, system is unstable system. Simple. Suppose I have one more example. If I have example number 6, yt equal to xt by t. So if xt equal to ut, then yt equal to ut by t. So when t equal to 0, yt is infinity, therefore unstable. If anywhere yt is touching infinity, then it will be unstable system. Okay, in this way we can check the signal for the stability, whether it is stable or not. So you can take more examples and solve those examples, test those examples for bounded input, bounded output. Okay, thank you. Thanks for watching.